All right, let's talk LangGraph. We're going to get into how you can build some seriously powerful AI agents. I'm not talking about basic chatbots here, but agents that can actually think, that can reason, and remember what you've talked about before.
So if you're a developer, you've probably hit this wall, right? How do you build an AI agent that can do more than just answer a single question? One that can actually reason, that can loop back on itself and remember what happened 5 steps ago. It's a huge deal for building anything really useful.
Well, that's exactly where LangGraph comes in. It's a library designed specifically to tackle this problem. The best way to think about it, it's like a special runtime for your agents, but it's built like a graph. This gives you total control to create those complex, loopy workflows that are, let's be honest, a total nightmare to code by hand.
Okay, let's get into the weeds. To really get LangGraph, you only need to wrap your head around 3 key ideas. That's it, just 3: state, nodes, and edges.
So the main thing you'll be working with is something called a state graph. Honestly, just picture a flowchart for your AI. That's pretty much it. The little boxes in your flowchart, those are your nodes, and they're literally just Python functions. And the arrows connecting them, those are your edges, and they just tell the system which function to run next. It's such a simple idea, but man, is it powerful.
Okay, let's look at some actual code here. See how straightforward this is? First, you define your state. That's all the data your agent needs to keep track of. Then you write your nodes, which again are just plain old Python functions. And finally, you wire it all up by telling the graph, hey, this node connects to that node. That's it. This basic pattern is the skeleton for your entire agent.
So just to really hammer it home, the workflow is always this. 1. Define your state. This is your agent's memory, its single source of truth. 2. Create your nodes. Think of these as the agent's skills, the actual things it knows how to do. And 3. You connect everything with edges. This is how you map out the agent's brain, its decision-making logic.
All right, now for a few best practices when you're designing that state. Seriously, use typedict or pydantic. It'll save you so many headaches by keeping your state clean and predictable. Also, try to keep your state as lean as possible. Only track what you absolutely need for the next decision. It makes debugging 1,000 times easier. Oh, and see that annotated syntax there? That's a really neat trick for automatically adding new messages to your history without extra code.
Okay, so we've got the building blocks down. Now, let's do the power move. We're going to build something way more interesting. A whole team of AI agents that actually work together. This is where LangGraph just completely blows everything else out of the water.
So, let's meet the team. First up, we've got the supervisor. Think of this agent as the project manager. It doesn't do any of the grunt work. Its job is to figure out who should do the work. Then we have our specialists, a research agent, who's our web guru, and a math agent, our resident number cruncher.
And the code for this is, well, it's just beautiful. Check out the multi-agent state. We've just added one little thing, an active agent key to keep track of whose turn it is. Simple. Then look at the specialists. Each one is basically just an LLM call wrapped in a function with a super focused system prompt. You are a web research expert. That's it. It makes the whole thing so modular and easy to understand.
The real magic here, though, is the supervisor. It is the brains of the entire operation. What it does is look at the whole conversation so far, and then it actually asks an LLM, okay, based on this, who goes next? And that decision is what guides the flow through the graph using what are called conditional edges. It's dynamic routing.
So let's walk through it. The user asks a complicated question. The supervisor looks at it and says, this looks like a research task, and sends it over to the research agent. The researcher goes out, finds the info, and adds it to the state. And here's the key part. Control goes back to the supervisor. It looks at the new information and decides what to do next. Maybe now it's the math agent's turn. It's this intelligent loop that makes it so powerful.
Okay, this is awesome for a prototype on your machine, right? But I know what every single engineer watching this is thinking. Yeah, but does it scale? So let's talk about the real world. Let's talk about taking this from a cool demo to a production service that can handle thousands of users all at once.
And I want you to burn this next part into your brain. This is the biggest gotcha there is. If you don't use a Redis checkpointer, your scaling is capped at exactly 1 user. 1. I'm serious. If you're just storing state in memory, you're dead in the water for production. The second you need to handle more than one person at a time, you absolutely have to have a shared checkpointer like Redis.
Yeah, the jump from prototype to production is huge. Your prototype, it's probably single-threaded, with state that disappears if the app restarts. Production? That's a whole different beast. You need a bunch of stateless servers that can all scale out, and they all talk to a central, persistent state manager like Redis. This is what lets a user's session survive a server crash and get picked up by any other server seamlessly.
So here's what a real, production-grade setup looks like. This is straight from the NVIDIA playbook. You've got a load balancer at the front, spreading traffic across, say, 10 or 20 fast API workers. The key is that these workers are stateless, they don't remember anything on their own. Instead, they all read and write the conversation state to a shared Redis instance. And for your permanent records, audit logs and long-term memory, you'd use something solid like Postgres.
And you know what? The code to make this happen is shockingly simple. You literally just import Redis Saver, point it at your Redis server, and pass that object in as the checkpointer when you compile your graph. That's it. And what this does is revolutionary. Now the state doesn't live inside one lonely little worker anymore. It lives in this central Redis database. So any of your fast API workers can grab any user's conversation, see where they left off, run the next step, and save it back. That is how you scale.
All right, we've got the architecture down. To finish up, let's do a quick-fire round of tips and tricks, the stuff you absolutely need to know to make your LangGraph app truly production-ready.
Okay, listen up. First, infinite loops. They will happen. Stop them by adding a max turns counter right into your state. Next, collaboration. Give your agents a shared scratchpad in the state where they can leave notes for each other. Here's a big one for your wallet. Use a cheap, fast model for simple stuff like routing, and only bring out the big, expensive model for the heavy-duty reasoning. Oh, and please, for the love of all that is holy, build dedicated error-handling nodes. Don't just let it crash. And of course, you need the standard production stuff: rate limiting, circuit breakers, and solid monitoring with something like Prometheus, so you can see what's going on.
And that's the whole journey. We went from the absolute basics, just state, nodes, and edges, all the way to a complex multi-agent system, and then we figured out exactly how to make it scale for thousands of users, all in just a few minutes. So now you've got the blueprint, you've got the core concepts, you've even seen the code. The only real question left is, what amazing, complex agent are you going to build?